Okay, so we've already definitely spent some time talking about these topics, but what we're going to do is today we're going more in depth than we have before. And then next class, we're going to also be covering velocity and speed, and we're going to start talking about acceleration as well. So, last class, we talked about this, and it's been forever since I've seen you, by the way. It's been almost a week. Last class, I told you that velocity was how fast and what direction, and speed is just how fast, but we don't care about direction. And it's not that they're super old definitions or we're not going to use these definitions, but today I'm going to give you more precise definitions. So make sure if I write it on the screen, you're writing it in your notes. By hand. Which, Brody, do you have a notebook?
Yeah, hold on.
Okay. And Ahmed, I can see one corner of your head. There, I can see a little bit more.
Sorry.
No, it's alright. I at least could see more than I could with a couple students earlier this week. Yeah, go ahead and copy this into your notes. And while you're writing, I am going to give you our new definitions, which again, just enhance the old ones. They don't necessarily replace. And Brody, as much as you can keep your camera on, I'd appreciate it. Thanks. Okay. I'm going to wait for you to copy this down. Our definitions as well as my shorthand. Those 3 lines, I did do those on purpose. Shorthand for is defined as. Or I always like to think of it as it's really, really, really equal to. So these two are our first equations we're really going to play with this year. Some pretty easy basic equations. Equations you've definitely seen before, especially the first one. And the second one is very, very similar to it. Now, of course, for equations, we do like to write them in shorthand. So when I switch to shorthand, just so I don't have to write out the words over and over and over again, this is how I'll write things out. And first thing I want to say is, why do you think I didn't use an S for speed? I used the V instead. It's mostly personal preference. Raise your hand if you ever have sloppy handwriting. All right, more than half of us. What do S's look like that I could confuse them with? Yep, what Conrad says. It looks like the number 5. So I don't use S because S looks too much like a 5. So I personally, and most teachers you will find, will not use an S as a variable in what we're doing, because it looks too much when we're handwriting it, especially, like the number 5. If you're using a computer, it really doesn't matter. But if you are writing it out by hand, it can be hard to tell which one you meant. So we want to just make it as clear as possible. So I do go ahead and steal the letter from velocity, because they are so closely related. But notice there is a difference between how I wrote the speed V and the velocity V. And that is, my velocity got this hat, this arrow hat. We put a hat on vectors. Anytime we care about the direction, we see a hat on it. So sometimes you'll see, like, force is a vector. We'll put the hat over it as well. Now, something to be aware of, I'm going to be completely honest with you, I'm not going to put the hat on all of our vectors every time. I will not always do that. And it's mostly just because I'm lazy. But here it will be important to me that when I want you to use a speed, I will make sure there's no hat. When I want a vector, I'm going to put a hat on it because I am using the same letter for both. But in other cases, like force, well, force definitely is a vector. We don't always write out what the direction is that we're caring about. Any questions so far? Okay. You guys are slightly more awake than my last class, but only slightly. Okay. I have some questions for you that I want you to consider. Copy those questions down, and then I'm going to give you a minute to answer the questions with what you think is right, but leave some space because I do want you to also write what we put down together. And Brody, you seem to have frozen. Brody, put in the chat for me when you finish writing this down. And Quinlan, you've gone all frosty. There we go. Bailey, what's your cat doing? Is she trying to steal your homework?
No, he just has a cup.
See, this is the advantage of Zoom class. We never could have pets attend in real class. Okay, Brody, gotcha. As much as you can, keep your camera on. I know some people are still having electrical and Wi-Fi issues, but it is helpful for me if I can see you. Alright, if you're still writing, keep writing, but I want to start answering these questions. Can speed equal 0? Tell me yes or no. Give me a thumbs up for yes, thumbs down for no. Okay, I see most of my thumbs. And I see Brody's thumb. Alright. I agree with a lot of what we're saying. I agree. It most absolutely can equal 0. Now, would you tell me when you can equal 0? What conditions would your movement need to have a speed of 0?
Not moving.
Perfect. Yes, if the object is not moving, it obviously has a speed of 0 meters per second, miles per hour, whatever units we're using, it's 0. Can speed be negative? Yes or no? Yes or no? Can speed be negative? Alright, I agree with the consensus, and I can't remember if the chat or if the emojis will allow Brody to show me that, but I agree with no. So why can speed never be negative? We talked about this last week.
Because distance can never be negative.
Your distance can never be negative. And I'm going to add to that, negative is a direction, and speed and distance are scalars, which means they do not use direction. today and mostly next time and definitely next week, we're going to start talking about how to apply these negatives in what we're doing. Okay, very similar questions now. Can velocity be 0? Yes or no? Got a couple answers. So far we got a split tie. Got Brody's. Okay. I don't see Ahmed's. But I would say you guys are like split pretty 50-50. So half of you are correct. The answer is this. So there are two situations, though, that can give me a 0 velocity where speed only had 1. One of them is the same as before. If the object is not moving, oops. It is possible to have a 0 velocity. But because we are dependent on displacement and comparing our final positions, it actually is also true that if the object returns to where it started, we would say that that object had a 0 velocity because the equation depends on our positions. And if we have the same position at the beginning and the end, and we're subtracting them, they cancel each other out. This means that, let's say, you start somewhere, and say you're going 10 miles per hour the whole time, and you have some crazy, crazy path. If you finish where you started, you would actually still have a velocity of 0 because you came back to the same place. So there are two ways. If you're not moving, velocity of 0, but if you return to where you started also, you will have a velocity of 0. So that's one that kind of trips the students up a little bit every year. Now let's try it with your thumbs one more time. Can velocity be negative? I see more of a consensus on this one. Still some differing opinions, although still close to 50-50. And then Jared kind of in the middle there. Oh, there you go. Okay. Okay, this one, the answer is on this one, I am going to put an example as well. If you decide north is positive, your direction is negative if you are going south. And the key words there really are these. When we talk about positives and negatives, there is no convention that says this has to be positive, this has to be negative. In physics, one of the perks is we get to decide what we want to call positive and what we want to call negative. So for example, in your math classes, we've already defined directions in terms of their positive and negative in math. But in physics, it could be that we decide to switch that. There will be times where we're going to want to, and it's all just based on personal preference and what the problem in the moment is calling for. In physics, it's kind of whatever you want. We don't have to follow what math does. Now, a question that came up yesterday is if I make my up negative and my down positive, how does that affect my x directions? And the truth is it doesn't. You do need to define positive and negative for y's one way, and then for x's separately. So whatever I do to y, it doesn't affect what I do to x. I have to make my own decisions for x. I think that's all I had on that. Okay, so thank you for your patience. Go ahead and copy this into your notes. Is that Lori over there over your shoulder, Abdul? I can't hear you, but I could hear when this is the tinkering that was happening around you. So it sounded like maybe your mic isn't connected to your headphones, it might be just coming through the computer. Because, like, Lori was just doing something to the computer. I think it's Lori. And I could hear that. But I can't hear your voice. Although now I'm not hearing anything from either of you. Thank you. Now, before we even start the problem, and keep copying it down, I know not everybody's done yet, but before we start the problem, there should be a big red flag that something needs to be taken care of before we can even start. Look at what I asked you, and look at what I gave you, and what does not agree with each other.
Don't you not write velocity in miles per hour?
Well, we prefer meters per second, but for this example, because I'm using miles and a time, it is still okay to write it in miles per hour. It's just we do like the metric system better. But for this problem, I'm going with the whole what are we used to. Believe me when I say later, we will definitely be doing things more in meters per second. There's something about what you said that is a red flag, though. But the fact I'm using miles per hour, that's not the issue. Focus on your units.
Isn't it the time, like it takes 18 minutes to drive to the school, but it takes 14 home?
Well, and that's okay that it takes a different amount of time. I'm figuring, like, you're hitting stoplights as you go, and maybe somebody's stopping you at the crosswalk, and that happens on the way to the school, but not the way back. As you tinker with this idea of especially time, though, I think that you guys are really close to what the issue is.
You gave us minutes.
Yeah, go ahead. Oh, Raiden, you froze. But I think you said it. Yeah, she's super frozen on mine. She said you gave us and who can finish her thought?
You gave us minutes, but it's miles per hour.
We have minutes here, but this is miles per hour here. So, remember MPH is miles per hour. And remember the word per in math always 100% of the time means divide. So what we have here is miles divided by hours. The fact that these are different than the units I gave means I have to take care of that before I can even start the problem. Okay, technically there's a way to do it in the middle of the problem, but I think for the sake of what we're doing, let's take care of it at the beginning. So, I want to know my average speed for the whole trip. My speed, remember, is distance over time. Let's go ahead and set this up and then switch our time. How far did I drive total in this trip? You're all muted.
10 miles.
10 miles, because it was at 5 miles plus another 5 miles. How much time go ahead and give it to me in minutes. How much time was I on the road?
18 minutes. Oh,
32, because it's going to
32.
be my first trip plus my second trip. Now, let's take that 32 minutes and convert it so we can solve the problem the way I'm asking. So going back to first week stuff. Or maybe that was second week we hit that. When I'm converting away from minutes and 2 miles, what unit goes on the bottom? Or minutes and hours, sorry.
Minutes goes on the bottom.
Minutes goes on the bottom because I want these to cancel with each other. Hours goes on top. Anytime you see a unit, a number, and anything, with one upstairs and one downstairs, they go away. And I like to put my units in first, and then I go back and I put in my numbers. How many hours to how many minutes?
$60.
60 hours to 1 minute?
Nope. 1 hour to 60 minutes.
Okay. And for the sake of what we're doing, I'm going to say don't even grab a calculator yet. We will later. Just leave it as 32/60ths of 1 hour. Not the comfortable way to leave it, but if you round it here, what I found is if you round it here, your answer will be a little bit further off later. So we're not going to do any rounding yet. Okay, so now my speed equation, which was 10 miles over 32 minutes, is now a little bit uglier because I have a fraction inside a fraction. But what I like about it is my units now are what I want. They're in miles per hour. Well, Jared, you look like you're about to sneeze. I was getting ready to say bless you. Okay. Now, let's see. Of you guys on the screen, Jared and Raiden, I think you're the only two that... And Miguel, you guys have had me before. If you don't remember my analogy here, I will forgive you, because nobody's remembered it so far. Actually, no, I've had one person remember it in all my classes combined. When you're dividing a fraction by a fraction, who do you have to think about? There's somebody very specific I want you to think about. Do you remember who it is? And Miguel and Raiden, you guys, it's been 2 years since you've had me last, so you guys definitely have had some time to forget.
Is it your sister?
Good job! I think you're the second person this year to remember. Okay, so for everybody who has not had me in class before, anytime you are going to divide a fraction by a fraction, you need to think about my sister. Now, even for the people who know they need to think about my sister, they haven't met her either, but they know, or they've at least heard the story. So, ever since my sister was about 2 years old, my favorite thing to do has always been to go sneak up behind her and flip her upside down. So, in this scenario, I am the first one. I'm the oldest in my family. I am the thing that comes first. And what's important about this is as I go through this process, my head and my feet stay where they normally would be. The head stays on top, the feet stay down below. And if you don't see feet, like this was just a 10, give me some feet by putting a 1 underneath it. Then my sister, what I love to do to her, she's the next girl in the family. There is a brother between us, but Miss WZ's sister, she gets flipped. So her feet and her head switch places, but for me, my head and feet do not. I don't get flipped, she does. Miguel and Raiden, does that ring a bell? Miguel, no. Raiden, yes. That's all good. Okay, so I'm going to bring this up anytime we're dividing a fraction by a fraction. Because it's just a good mathematical practice to play with this, because from this point, through the rest of the time you do math in your life, at least through college, you're going to be doing a lot of fractions. Fractions are going to pop up in your science classes, in your math classes, and it's kind of a shame that your elementary school teachers, they teach you fractions first, They really did. But once they switched to decimals, they never look back. You hardly do any fractions. But these fraction rules are going to be things that are going to help you in every class that's going to come by. So I'm going to remind you of the fraction rules as we go to make it easier for you. And what's convenient then is, with fractions, you multiply straight across. So I end up with 10 times 60 over 1 times 32. When you're dividing fractions inside fractions, even when you're using calculators, it's easy, if you leave it in that form, to make a mistake. Especially, honestly, if you're using calculators. And then, of course, our unit's still on the outside. Miles per hour. And, of course, also, 1 times anything doesn't really matter, so I'm going to get rid of that. Would you now, with your calculators, please tell me what is 10 times 60 divided by 32? And if you have an electronic device, you have a calculator.
I got 18.75.
I got 18.75.
All right, and what I like...
Well, got 18.75.
Perfect. I never believe an answer till I hear it at least 3 times, so you got it. Okay. And that's what I got too. Anytime we do calculations, I will ask for some confirmations, and you guys were so quick on that. That's perfect. So this means that it took us, we were at an average speed of about almost 19 miles per hour. Sometimes maybe we hit a stoplight. Maybe we got stopped at the crosswalk. Maybe there was just a little bit of extra traffic, different things happening. But some things slowed me down here or there. Does this make sense? Does this mean we went 18.75 miles per hour the entire time exactly? No, like I said, we definitely slowed down, which also means there were times we were going faster than this. This is just what it averaged out to be, based on our equation. Now, one more question, because all of that was part A. What was your speed? Average velocity actually is going to go a little faster in this problem. In this situation, could you tell me what my displacement over my time would be?
Wouldn't it be 0 displacement over 32 minutes?
Perfect. And what does that simplify to?
0.
Because we came back to where we started, you actually have a displacement of 0. Over, and I'm going to go ahead and put this because I'm going to put 0 miles over 32/60th hour, so I'm still in miles per hour. But really, it doesn't matter because you still get 0 miles per hour. Is your velocity. And in going back to what we said before, because you finish where you started. There is a problem on your homework that's going to look like this. Different numbers. I am recording this. I don't see where you went, Max, but I am recording this. Oh, there you are.
Alright, yeah, I'm just having internet problems.
Yeah, well, obviously I am too. And I will say, too, that some of your last lessons I haven't gotten uploaded because the rendering something went wrong. But I have recorded this lesson for each class period, and I think I've gotten my 8A lessons up. And I do plan to put yours up as well. Or I've gotten them on YouTube. I haven't converted them over to Canvas yet. But it does look like it's working for me this time. Okay, how we doing? See some thumbs ups? Overwhelming you yet? Not quite? Alright, that's good. Okay, we are almost done. I know synchronous time, my bell went off, but I do have a little bit more I want to cover for your homework. And realistically, I'm actually going to start this over here. If I'm going too fast for you, I do apologize. Head to the recording and see what you miss. What we're going to talk about for a moment is instantaneous speed. Versus average speed. Instantaneous speed just means the speed in the moment. So if you're driving in the car, you look down at your speedometer, it's just the speed you're going in that moment. Whereas average speed, we're going to look at your entire trip. Does this graphic look familiar to any of you? Seen it at least once or twice, right? Okay, this is something that CPM brings up over and over and over and over again. What we have done so far is we've definitely, in that last problem, we went between the equation and the situation. What I want to do next is just start to introduce you to how we can use the table or the graph in ways you might not be expecting. So, for this, I'm actually going to pull up your actual homework for the day. Today's will include another worksheet. We will do plenty of worksheets, but I also will add, we're definitely not going to do worksheets every day. Okay. And because it's a PDF, my normal ways of writing on the screen won't work, so I'm going to use the annotate feature. Alright, so in our first example, we have somebody that is, I don't remember if they're running a race or just going for a run, I don't know. Oh, let's see, it says the first 10 minutes of a teacher's trip along the expressway to school. So, in this example, we are given our data as a table where we're told at 0 minutes they haven't moved yet. After a minute, they've gone 0.4 miles. At 2 minutes, they've gone 0.8 miles. So if I were to graph just in one dimension, just each tick mark will be 1 minute. I'm going to see something like this to show me how far they've gone in each minute. Does that part make sense? Okay, 4 of you. Okay. Could you tell me how far they traveled in 10 minutes? Would you tell me now? How far did this teacher travel in 10 minutes? Based on the table. Is it big enough for you to see? No?
76 miles.
Say it louder.
76 miles.
7.6 miles. There we go. Is that better? Okay. They went 7.6 miles in 10 minutes. So, if that's asking you for the average speed, and again, this is a problem from your homework. I'm not going to do the whole thing for you, but I'm setting it up for you. What you want to know for average speed is going to be the total distance that this person has traveled divided by the total time. So, the total distance, what you just gave me, is 7.6 miles. And how long did it take them to travel that?
10 minutes.
10 minutes. And notice that they want it in miles per minute, so they're not going to make you convert like I did on this problem. You just divide that, you'll have your answer. Okay, so that's the first problem. Basically did it for you, you just need to plug it in the calculator. But for the next piece, it asks us this idea of maximum speed. What that means is which minute were they traveling the fastest? This means you're going to have to do the calculation several times over. So you're going to have to find the velocity distance over time just here. 0.4 minus 0 over 1 minus 0. And then you're going to have to do it here. Distance over time will be, you travel 0.8 minus 0.4. 2 minus 1. And you do want to do kind of more the velocity equation because, like say, going from minute 1 to minute 2, you really only traveled 0.4 miles. You did not travel 0.8 in that minute. So you want to figure out minute by minute what those individual speeds were and figure out which one gives you the biggest number, and that will be the maximum speed. And you're going to give me an answer that would say, like, the maximum speed was from this minute to this minute. Does that make sense? Okay. Abdul, tell your friend to go away. We're still in class. Say, hey, get out of here. Okay. Alright, now, how this works on the graph. There is one particular topic in your math classes that I think that you have probably done to death. And that is, if I give you 2 points on a graph, what have you typically done with those 2 points? And I mean going all the way back to like middle school.
Line equation.
What kind of line equation?
Linear.
Can you give me an example?
Y equals mx plus b.
You have done this thing to death. Now, you're not actually going to use the whole y equals mx plus b. It's really just this piece you're going to use. And that is slope. Now, this thing that I'm about to show you, you're going to use on this problem in your homework, but only problem 10. And then on Thursday when we meet, our whole lesson will be on using tables, but especially using graphs. I want you to look at something here. Your equation for slope that you learned years and years ago. What is the equation for slope? Blank over blank. Fill in the blank.
Rise over run.
Rise over run. And Abdul, I see yours too. Rise over run. Rise, remember, was the change in your y's. Run was the change in your x's. So in other words, something like y2 minus y1 over x2 minus x1. I want you to look at what we have on the y-axis and on the x-axis. If I were to take any 2 points and talk about them in terms of their x value and their y value, do you agree with me that it would be proper to change y's to d's and x's to t's? Since distance is the thing that's on the y-axis, time is the thing on the x-axis. So I'm going to update my slope equation to reflect that. And, in fact, I could also talk about it in terms of final minus initial. Which I know kind of got sloppy there at the end. Which, that right there should look like something we've been doing all class period. I just got slope equals df minus di over tf minus ti. D over t. What is d over t again?
Distance over time.
Oh, well, but I mean, what does that equation equal?
Slope.
Yes, but earlier in the lesson. I'm looking for a different word. One started with an S, one started with a V. Abdul, you got it. Oh, and then Conrad, what were you saying? Or Jared? Speed. And more appropriately, because we are using this whole idea of final minus initial, it's even going to be more proper to say velocity. Because, first of all, think about negatives. Can your slope be negative? Slope can go down. And velocity is allowed to be negative, where speed can't. Speed, you'd have to take the absolute value. It turns out let's see, maybe I can write off to the side. It turns out for a distance time graph, your slope is equal to your velocity. Now, this is only true when you have distance on the y, time on the x. We will be teaching you other graphs where you've got other things there, and your slope will mean something different depending on the graph you're dealing with. But for a distance time graph, slope is the same thing as velocity. I'm going to erase some of this so we can talk about how to handle this problem. On this problem, they ask you for his greatest average speed, which is, again, anytime it's looking for the word greatest, it does mean the instantaneous. Even though they use the word average, it does mean find the greatest speed in this amount of time he ran. So, what this means that you're looking for is you're looking for the steepest or the biggest slope. And so you would need to find the slope of each line separately to figure out which one would be the biggest or the steepest. In class on Thursday, we're going to focus almost entirely on problems that look like this. This one is just to introduce you to the topic. Okay. Any questions so far? Does anybody need what's on the screen? Wave at me if you need what's on the screen. And Brody, I haven't heard from you for a little while. You good? Okay. All right, let's go through what I need from you. Oops. Clear. Exit. There. All right, so a couple things here. First of all, you have your discussion that's due today. This will close at midnight today. So as soon as we finish the lesson, log off and do the discussion. Just get it done. And it's just, my discussion question is just, tell me something you learned today. Your quiz and your assignment are both open until Friday. They are due next class period because I think that if you put everything off until Friday, your Fridays are going to be